in Lesson 6-4, we're going to take a second day to continue to work with line plots. This time we're going to look at class height data. Go ahead and grab your whiteboards, your whiteboard marker, your math journal. You also will need a calculator, so grab that as well. For your warm-up today, if you take either this improper fraction of 5/3 or a mixed number such as 1 4/5, I would like you to rename each fraction as a mixed number if it is an improper fraction, or as an improper fraction if it's a mixed number. So for example, number 1 is an improper fraction. You're going to change it to a mixed number. Remember, mixed number is just a whole number plus a fraction. For number 2, you're going to take that mixed number and turn it into an improper fraction, where the top number is larger than the bottom. The numerator is larger than the denominator. And number 3, you're going to take that improper fraction and change it to a mixed number. For example, 5/3 would be the same as saying, how many 3s are there in 5? Well, there's 1. 2 is our remainder, so we write that as a numerator. Our denominator never changes. So this one would be 1 2/3. Would you go ahead and change number 2 and number 3? Pause your video. You shouldn't just wait for me to solve it. Be a person that can do what's expected even when no one is watching. Number 2, I am going to change this whole number 1 into a fraction that has a denominator of 5. In order to make it equal to 1 whole, I'm going to put the same number on the top, the numerator, as the denominator. So 5/5 is the same thing as the 1 that I borrowed. Now I can take 4/5 plus 5/5 to give me 9/5. And 21/5, how many 5s are there in 21? Well, there's 4 and a remainder of 1. The remainder becomes the numerator. The denominator does not change. So 21/5 is the same as 4 and 1/5. Go ahead, erase your whiteboard, number 1 to 3 again. For number 1, you're going to ask yourselves how many 3s are in 19 and write this as a mixed number. Number 2, you're going to change 4 1/8 into an improper fraction where the numerator, the top number, is larger than the bottom. And for number 3, you're going to change that mixed number into an improper fraction. I will do number 2 for you. There are 2 different ways you can do it. There is a shortcut. You can take the denominator times the whole number and then add in the numerator. So I could take 8 times 4 is 32 plus 1 equals 33, and my denominator does not change. It stays 8s. Or I can think about 4, changing that so it has a denominator of 8, and I would do that 4 times because 8/8 plus 8/8 plus 8/8 plus 8/8, each one of those equals 1 whole. 1 2 3 4. 8 plus 8 plus 8 plus 8 is 32/8. 32/8 plus the 1/8 that is there gives me 33/8. Go ahead and solve for number 1 and 3. You should have paused the video and solved. So let's take 19/3. 3 goes into 19 6 times, which is 18. Our remainder is 1. Our denominator does not change. It stays thirds. So 19 thirds is the same as 6 1/3. 2 3/10, I'm going to borrow from that 2 and make that equal to 1 whole and 1 whole. 10 plus 10 plus 3 is 23 tenths. Tenths does not change. Go ahead and erase your whiteboard. We're going to go ahead and move into our math journal. We did a line plot the last lesson in math that had to deal with pencil length. We're going to move to page 206. And you'll have to turn your math journal to the side. This says class height data. So we're going to have to just assume that we can measure all of our heights. And so I am going to go ahead and give you that data over on the side. If we were all in person, I would have you measure a partner, write that partner's height on a Post-it note, and then we would put those up on the board. So imagine that we measured a whole bunch of fifth graders to the nearest half an inch. Let's go ahead and write this information in. You have a weight space off to the right where I've put the box. Would you please add these heights in? Let's go ahead and put in these measurements. We had one fifth grader who was 56 inches. And that's the symbol, the two little hash marks. We had 57 and a half, 52 and a half, 52 inches, another 56 inches, 54 and a half inches, 54 inches. Write these all down with me. 57 inches, 57 and a half inches, 53 inches, 52 inches, 56 and a half inches, 54 inches, 59 inches, 53 and a half inches, 51 and a half inches, 58 and a half inches, 57 and a half inches, 58 inches, 54 and a half inches, and 57. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 students in this class. So if you want to measure yourself to the nearest half an inch, you have to find a tape measure and have someone help you. So if you want to fill out number 1, you sure can. But what we do need to fill out is we need to fill out the labels for this line plot. So the title would be Height of Fifth Graders. And because it's a title, we want to capitalize everything but the word of. We want to go ahead and write inches down at the bottom because we measured in inches. And then let's go ahead and answer the questions before we graph our data. The largest value in the data set. What is the tallest student? I believe it is 59 inches. So I'm going to write 59 inches. The smallest value in this data set is, who is the shortest person? I believe it's 52. So a good number for the line plot to begin with would be 52. And we would want to make sure that we end with 59, unless we had someone who was taller than 59. We measured each student to the nearest half an inch, so we should label number lines with half an inch. So we're going to have to write fairly small. So we're going to start with 52 inches. Now, I'm not going to mark everyone in between because it's really, really small. So I am just going to mark every inch, but know that in between this one would be 52 and a half. Then it would be 54, 54 and a half, 55, 55 and a half, 56, 56 and a half, 57, 57 and a half, 58, 58 and a half, 59, 60, and you could keep going. We didn't have anyone who was that height in inches. But just know, in between, this would be 52 and a half. Now we're going to go ahead and represent that data with X's. So let's start with 56 and go ahead and cross it off. Put an X. 57 and a half. Remember, that would be halfway between 57 and 58. 52. 56. 54 and a half. 54. 57. 57 and a half. 53 inches. 52 inches. 56 and a half. 54 inches. 59 inches. 53 and a half inches. 51 and a half. There's where I made my mistake. 51 and a half. Add that on there. And also change this to reflect 51 and a half. And I need to change this as well. $58 and a half, 57 and a half, 58, 54 and a half, and 57. On the next page, page 207, we have some questions to answer about this particular line plot. It says, use your line plot about student height to solve the following problems. How many students are included in your data set? So I'm going to be going back and forth as you will as well. Let's again count how many. 1, 2, 3. You can count the numbers over here, or you can count the X's. So maybe I would count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 students represented with their heights. What is the most common height represented in your data set? That would be called mode, the number that occurs most often. So where do we have more X's above than any other number? That would be this one here with 3 X's, and that's 57.5. So 57.5 inches is most often the mode. How many students in your class are 55 or more inches tall? So we have to start with 55, which would be here, and anything greater than that. So count up the X's that come at 55 inches or after. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students. What is the difference between the largest height measurement and the smallest height measurement? So let's go back. Remember, I messed up that one. So 51.5 is our smallest. 59 is our largest. So I would take 59 inches minus, and what was our smallest? 51.5 inches. And let me show you what I'm going to do to solve that. So if I take 59 and subtract 51.5, I cannot subtract 1/2 from nothing. So I'm going to borrow from the 9 and make this an 8. Take that 1 inch and make it equal to 2 halves. Remember, when you have the top number and the bottom number, it equals the same. It equals 1 whole. So I just took that 9 inches, made it 8, and made that 1 inch equal to 2 halves. So now I can subtract 2 halves minus 1/2 is 1/2. And 8 minus 1 is 7. So the difference between our shortest 5th grader and our tallest 5th grader is 7.5 inches. Number 5, what is the total combined height of all the students in your class? So we are going to add together all of the 20 students' heights. Now here's what I'm going to do. I want you to use a calculator. Instead of using a half is the same thing as 5/10. So whenever I see someone that's 57.5, I'm going to put 57.5. So we are going to go ahead and add together all of these heights. So get your calculator ready. Go ahead and add all of those heights. I am not going to read them aloud. I want you just to go ahead and do this with me. I'm going to pause the video while I'm adding them up. So I added it together several times until I got the same answer at least twice. So if you didn't get it, this is what I had. I had a total of 1,019 inches, 19.5 inches. And I just wrote that as a decimal. So how would you find out what the average height was? I know this isn't a question on your page, but all you'd have to do is on your calculator, take that 1,109.5 and divide it by the number of students. Divided by 20. That would give you the average, what we call the mean. So if I took 1,019.5 and divided it by 20, I would end up with something like this. 55 and 475 thousandths. If I wanted to round that to the nearest tenth, I would say the average 5th grader is 55 and 5/10 inches, or 55.5 inches. Imagine that you and your classmates decided to lie down on a baseball field starting at home plate and placing yourself head to toe along the first baseline. How close would you come to reaching first base? So this home plate's there, first base is here, second base, third base. Remember, this is in inches, and here we're talking 90 feet. So if we had 1,019.5 inches, we have to divide that. To convert that to feet, we would have to divide that by 12. So I'm gonna, my calculator, press 1,019.5 divided by 12 inches in a foot. So we have 84.95. We'll just cut it off there. So let's say we have 85 feet. Because remember, this is in terms of inches. So we want to convert that to feet by dividing by 12. Would we cover the exact distance from home plate to first base? Well, altogether, we were just under 85 feet. Would we not reach all the way to first base? We would be short by about 5 feet. How did I solve the problem? I took 1,000, write this down, 19.5, and I divided by 12 inches in a foot to get 84.95 feet.